Past year questions. This video we shall discuss the further pure paper 1 2020 May June paper 12. Let's take a look at question number 1. We have cubic equations here where the A, B, C are constant and it has the root of alpha, beta, gamma, where the product of the three roots is -1. We want to find the value D. So the value D is actually negative of alpha, beta, gamma. So it's actually -1 and the D is 1. Okay, so this is the answer for the number 1A. Now we move on to the B. Is we want to form a new cubic equation where the root are now alpha plus 1, beta plus 1, and gamma plus 1. So we just need to use a substitution of y equal to x plus 1, then we will get x equal to y minus 1. So your cubic equation, original cubic equation is this. But the D we already found is a 1. D is a 1, so we just write a plus 1. Okay, then now we want to expand them. We only want the answer in terms of coefficients of B and C. We do not want to see D anymore. So change the x become y minus 1 cubed. Then this will be y minus 1. This will be, oops, sorry, this is a y. Then this is a x, sorry. So this will be a y minus 1 plus 1. Expand them using the binomial expansion. Then you will get this. This is a y square minus a 2y plus 1. This is the cy minus a c plus 1 equal to 0. So you can see that this one can be cancelled. And you group them together, the y cube, the y square in the same term, same terms, you group them together. Then this will be a 3 minus a 2b plus the cy plus the b minus the c equal to 0. Okay, so this is what we have for the answer in the question number 1b. Move on, we have a 1c. It is given that this gamma plus 1 is equal to negative alpha plus 1. So gamma plus 1 is equal to the negative alpha plus 1. We can actually make it become alpha plus 1 plus the gamma plus 1 is equal to 0. Okay. So then from the part B, we know that the alpha plus 1 plus the beta plus 1 plus the gamma plus 1 is this negative e minus 3. So, but because this add together is a 0, so therefore we just need to say that your beta plus 1 is equal to this. I don't plan to write it as a 3 minus b because you can see that I have a b minus 3, I have a b minus 3 here. So I just leave it as a negative bracket, b minus 3 will do. Okay, then this is the sum of the three root. Now we want to go for the product of the three root. Product of the three root will be this. Product of three root, the three root multiplied together will give you this negative b minus c. Negative b minus c. Then we know that alpha gamma plus 1 is equals to the negative alpha plus 1. Okay, so we know this relationship. Then we can make it become negative square, and beta plus 1 is a negative b minus 3 is equal to this. Okay, then we will be having this one cancel off. you will have gamma plus alpha plus 1 square, b minus 3 is equal to the negative of the b minus c. Okay, so over here, we still haven't complete yet because we still need to settle the gamma alpha plus 1 in terms of b and c. So what should we do is that we have found the sum of root. We have found the sum of the product of 3 root. Okay, so now we want to go for the sum of the product of 2 root. Okay, so this is one part. This is one part. So now we go for another part, alpha plus 1 multiply beta plus 1, alpha plus 1 multiply gamma plus 1 plus the beta plus 1, and then gamma plus 1. This will be equals to the value here. Okay, 3 minus 2b plus c. 3, I call this one equation 1, I call this one equation 2, then this one is a 3 minus a 2b plus the c. Okay, then you can see that we have a common factor, and we have, after this, when we factorize it out, you will get this result. So you can see that you have a beta plus 1, you will get alpha plus 1 plus the gamma plus 1. Then this one, it will be negative. And then because of this result, okay, then you will get now negative alpha plus 1 squared is equal to the 3 minus 2b plus c. Then this will be a 0. This whole thing will be a 0. So you get negative alpha plus 1 square is equal to the 3 minus a 2b plus the c. Then now we see that this is what we want. Okay, so you will have 3 here. Maybe I make it become alpha plus 1 square. Make it become this. That is my equation 3. So 3 into 2. Then I will get negative 3 minus the 2 beta plus c multiplied by beta minus 3 is equal to the negative of beta minus c. The negative and the negative can cancel off. So therefore, you have a c minus a 2b plus 3 multiplied by b minus 3 is equal to the b minus c. Done. That is the answer for the question number 1C. Okay, so now move on. We have a question number 2. We have a mathematical induction. Prove by mathematical induction that the 7 power 2n is divisible by 12 for every positive integer. So first of all, we let this expression call Fn. 7 power 2n minus 1. Okay, so when the n is equal to 1, you have a f1 is equal to the 7 square minus 1, it will be 48. Is divisible by 12. So it's true for n equal to 1. Then assume true for n equals to k. That means the fk, which is 7 power 2k minus 1, is divisible by 12. Okay. Then now when n equals to k plus 1, so you will be having f k plus 1 is equal to the 7 power 2 of the k plus 1 minus 1. And you have make it become 7 power 2k plus 2 minus 1. And you take the fk plus 1 minus the fk. So you will get this. Then your fk, this one is fk plus 1 minus the fk. Then you can see that this one can be cancelled. So your fk plus 1 is actually equal to the fk plus the 7 square minus 1 power of 7 power 2k. So it will be fk plus 1. This one is a 48. So because of fk plus fk and 48 multiplied by 7 power 2k is divisible by 12. So therefore, fk plus 1 is divisible by 12. True for n equals to the k plus 1. So conclusion, by the BMI, 7 power 2n minus 1 is divisible by 12 for every positive integer n. Every positive integer n. Done. This will be the answer for question number 2. And move on, we have a question number 3. So what you can do over here is that follow the instructions given. We just need to expand and simplify them. So you can see that x n minus the square root of x power 2n plus 1 multiplied by x power n plus the square root of x power 2n plus 1. So you can see that actually this one is like a minus a b, then multiply by a plus b. Okay, so it's actually similar to these expressions. And if you expand them, you're supposed to get a square minus a b square. Okay, so over here we can actually make this become our a square minus the square x power 2n plus 1. Okay, the square root and the square already offset, so you can actually write it in this way. Then you will get x power 2n minus the x power 2n minus a 1. Okay, and then you can cancel it off, so you can get negative 1. Then therefore the negative x power n plus the square root of x power 2n plus 1 is actually negative 1 over the x power n minus the square root of x power 2n plus 1. But the question is they want to have the negative at the other side. So you can show it in this way. X power n minus the square root of x power 2n plus 1 is equal to the negative xn minus the square root of x power 2n plus 1. Shown. That is the answer for number 3A. Then move on. We have a 3B. We let the UN look like the expression like this. Then use the method of differences to find the sum of the UN from 1 until n. So over here, they say method of differences, but over here we have a plus. We don't have a minus over here. So we need to make use of the result in part A. So from part A, our UN x power n plus 1 plus the square root of x power 2n plus 2 plus 1 plus the 1 over the x power n minus this. Okay, so from the part A, we actually can change them to become minus the xn plus the square root of x power 2n plus 1. Okay, so this is from part A. So now the sum of the n equal to 1, the un from n until 1 equal to 1 to until n. So this one is actually it belongs to this x power n plus 1 plus the square root of x power 2n plus 1 2n plus 2 minus this. Okay. Then by replacing the n equal to 1, you get x squared plus square root of x power 4 plus 1 minus the x power 1 plus square root of x squared plus 1. That is the first term when the n equal to 1. And when the n is equal to 2, then you will get this one as x power 6. This one will be x squared plus the square root of x power 4 plus 1. And you can see that it can cancel in such a way. And the pattern will continue until the last two terms. So the last term over here, we can write the last term will be x power of n plus 1 plus the square root of x power 2n plus 2 plus 1 minus this. Okay, then before that, it will be x power n plus square root of x power 2n plus 1 minus this. X power the n minus 1 plus the square root of the x power 2n minus 2 plus 1. Okay, so they can cancel in such a way. So at the end, you will get this result as the x power of n plus 1 plus the square root of x power 2n plus 2 plus 1 minus the x power n minus the x minus the square root of x power 2 plus 1. Okay, so this is how you get the sum of the n. Okay, so that is the answer here. Done for the part B. Move on. We have a part C. We want to deduce that the sum of infinity, and we want to find the set of value x so that the sum of infinity is converged. Okay. So our sum of infinity, that means we just write is sum n equal to 1 until infinity. is actually the limit of the n goes to infinity for the expressions that we have found just now. So we just copy from the answer in the part B. This is the answer in part B. So we are dealing with n to infinity. And in order to be converged, okay, in order to be converged, when the n go to infinity, this one want to go to 0, this one want to go to 0. Okay? And this is not affected by the power of n. Okay, so we only focus on the x power n plus 1. So for the infinite series to convert, we need to let x power n will need to be approached to 0 when the n approach to infinity. Okay. Then therefore your x must be between 1 and -1. Okay, so this is the conditions. This is the set of value x for which to make sure that it's converged. So we need to mention this. After that, we want to find the sum. Okay, we want to find the sum. So when it is therefore the sum to infinity, that will give you 0, 0. It will be giving you a 0 plus square root of a 0 plus 1 minus a x minus the square root of x squared plus 1. That will equal to the 1 minus x minus the square root of x squared plus 1. Done. This will be the answer for the question number 3C. Move on. We have a question number 4. We require to give the full details of a geometrical transformation in the xy plane represented by the matrix A. So over here, if you can memorize the pattern of the matrix over here, it is actually a reflection in the line of y equal to x. So you just write that this is a reflections in the line y equal to x. Done for the number 4a. Then move on 4b. Now we want to do the same thing, give the full details of geometrical transformations in the xy plane represented by the matrix B. So B is given as half sec 3 over 2, negative sec 3 over 2, and half. It is actually cos pi over 3, sine pi over 3, negative sine pi over 3, and cos pi over 3. So therefore is representing a rotations. Pi over 3 radian anti-clockwise, and then about the origin. That is the answer for the part B. Okay, now we move on to the part C. Now they're saying that you have a triangle DEF in the XY plane is transformed by AB onto the triangle PQR. Show that the triangle DEF and the triangle PQR have the same area. So since it's transformed by the matrix of AB, so we need to multiply the AB. This. Then if you multiply them, then you will get this one as the sec 3 over 2. This is a half. This is a half. And this is a negative sec 3 over 2. So the determinant of AB is actually negative 3 over 4 minus 1 over 4 is equal to negative 1. Okay. So the formula, because this is the image, this is the object. Okay. So the area of the image, the formula is actually equal to the determinant of the AB multiplied by the area of object. But we know that the image actually is called PQR. Then your object will call DEF. And because the determinant of AB is a negative 1, and if you modulus it, so therefore, you have shown that the area of triangle PQR is equal to the area of triangle DEF, shown. Okay, that is the answer for part C. Now we move on to the part D. Find the matrix which transform PQR onto the DEF. This is the image. This is the object. You are looking for image go to the object. Just now object go to image is AB. Then this one, it will be the AB inverse. So the AB, we already know is, just now we found the AB as sub3 over 2, half sub3 over 2. This is a negative sub3 over 2. Okay, so now the AB inverse is actually 1 over the determinant. Minus is a negative 3 over 4. Okay, then this one you swap the value, negative sub3 over 2 and sub3 over 2, you swap. This one you put negative sign. Expand, simplify, then you will get this answer as a sub3 over 2, half, and negative sub3 over 2. That is the inverse of the matrix AB. Okay, move on. We have E. Now the E is, we are looking for the invariant lines through the origin of the transformation in the XY plane represented by the AB. So we already know that the AB is sub3 over 2, negative sub3 over 2. This is a 1, 1. Half. Okay. So now we have an invariant line y equal to mx. Then the y prime will equal to the mx prime. So you just take the AB. Multiply the object, which is a xy. But you can write it as a xmx. This is a x prime and y prime. You can write it as a mx prime. So from here, we will get this as a sub3 over 2 plus the half m x is equal to x prime. That will be equation number 1. Then half minus a sub3 over 2 m is equal to the mx prime. That is your second equation. Take the 1 divide 2. You will get sub3 plus m over 2 divided by the 1 minus the sub3 m divided 2 is equal to the 1 over m. So you can cross multiply. Then you get this. join together. That is your m. But we need to find, this is the m square. Okay, we need to find the m using the quadratic formula. Negative b plus minus square root of b square minus 4ac divided by 2a. Then therefore, your m will be 2 minus 3, and another value of m will be negative negative 2. Negative 2 minus 3. Yeah, correct. So this is the m. Then therefore, your invariant line y equals to the 2 minus 3x. Another one is negative 2 minus 3x. Done. This will be the answer for the question number 4. Move on, we have question number 5. Equal to the ln 1 plus pi minus theta, where the theta is between 0 to pi. The question 5a, they want you to sketch the curve C and state the polar coordinates of the point C that is furthest from the pole. So what you need to do for this question is we need to build the table. So this will be a theta 0, this is the R. And then the theta can start from 0, and then maybe pi over 4, pi over 2, 3 pi over 4, and then until pi. So when the theta equal to 0, if you use a calculator, press the value and leave into the 1 decimal place, is around 1.2, 1.4, 1.2 here, 0.9, 0.6, and then 0. Okay, so now we are ready to sketch the graph. So according to the coordinate that we have, we just need to draw the initial line and the vertical line. So this is the pole, and this one is the theta equal to the pi over 4. This is the theta equal to the 3 pi over 4. Theta equal to the pi. And then we can start to plot the point R, which is around 1.4 here, then 1.2, 0.9, 0.6, and then 0. So if you combine all the curve together, then your graph will be around this, like this. Okay, so this will be the answer for the number 5A. Move on, we have a 5B. 5B, they want to use the substitutions u equal to the 1 plus pi minus theta, or otherwise show that the area of the region enclosed by C and the initial line is given as this. So over here, the area is actually bound and closed by the curve and the initial line, which means that it's the areas over here. So that means you need to integrate from 0 until pi. Okay, you need to integrate the area from 0 until pi. So over here, just write area is equal to the half 0 until pi r square d theta. So we do not need to write r square anymore. Just direct write the r is a ln 1 plus pi minus theta, the whole thing over here, you square it. Okay, so we are required to use the u equal to the 1 plus pi minus theta as a substitutions. You need to find your du d theta, and you can get your d theta is a negative du. Then when the theta is equal to 0, your u will be 1 plus pi. and the theta is equal to pi, then your u will be the 1. So by using the substitution that we have calculated over here, we can actually just change the 0 here, become 1 plus pi. This become 1. This one become log u bracket square negative du. So the negative over here, we will need to make it positive. If we make the du here become positive, then these two values here need to be swapped. So you will get this one as a ln u squared. Okay. So now our questions remain as simple as just need to integrate the ln u squared. So how are we going to integrate ln u squared? We have to use integration by part. So if you use integration by part, then this one, it will be the u ln square u, and then minus the integrate u, and then 2 over u ln u du from 1 until 1 plus pi. Then you need to repeat this process again, but before you repeat, you will simplify them, become 2 ln u first. So you can see that we need to do the integration by part one more time. So this time you will get 2. You get a u ln u minus the integrate the 1. Then at the end, you just need to finish the integration, the last part of the integrations. Just need to finish it. So you will get this one as the ln square u minus the 2u ln u plus the 2u, 1 and to 1 plus pi. Okay. So now we need to substitute the value inside. So if we substitute the value inside, then you will get this as the 1 plus pi ln square 1 plus pi minus a 2 1 plus pi ln 1 plus pi plus 2 1 plus pi minus the 2. Okay, because if you put 1 inside here and here, you will get 0. Okay, only that when you put the 1 inside here, you will get 2. Okay, so this is what we have. Then we just need to expand them carefully. This part, if you expand and simplify, you will get 2 pi. Okay, but the 2 pi need to multiply by half. There's a half in front here. So over here, you can get this one as a half, 1 plus pi ln 1 plus pi. Okay, and then factorize it out. You have this as a ln 1 plus pi. And this will be 1 plus, you will have minus 2. And then plus the half times 2 pi. Simplify it. Then you will get the answer. This will be ln 1 plus pi minus 2 plus pi. So shown. Okay, that is the answer for the number 5B. So now we move on to the 5C. We want to show that at the point C, the furthest from the initial line is this. Okay, and then verify that these equations has a root between 1.2 and 1.3. So what you need to do is, first of all, you start from here. 1 plus pi minus theta. in order to get the furthest from the initial line is this. So to get the furthest from the initial line, that means you're looking for y max. So to look for y max, you need to make the r become y. And to make the r become y, you just need to multiply by sine theta. So you get r sine theta equal to the sine theta ln 1 plus pi. Then this is a y equal to the sine theta ln 1 plus pi minus theta. Your dy d theta is equal to keep the left, differentiate the left, differentiate the right, minus plus the keep the right, differentiate the left. So this is what we have. In order to get the further distance or the maximum of y, you need to let your dy d theta equal to 0. That will give you sine theta over the 1 plus pi minus theta equals to the cos theta ln 1 plus pi minus theta. And we just need to cross multiply. You make the cos theta go down here to the left hand side, and your denominator 1 plus pi minus theta move to the right hand side. And if you simplify it, then you will get this as the tangent theta, okay? And then minus the 1 plus pi minus the theta ln 1 plus pi minus the theta equal to 0. Okay, so this the order is different. Okay, you can see that the tangent theta is behind. So what you need to do is just need to rearrange them. Okay, you just need to rearrange them. Then you will get the form that you want to show. So you just make it become the 1 plus pi, put it in front, then minus the tangent theta is equal to 0. So shown. Now we want to show that the root is between 1.2 and 1.3. So we just need to let the whole thing over here as a f theta, which is a 1 plus pi minus a theta ln 1 plus pi minus theta minus a tangent theta equal to 0. You just put 1.2 and 1.3 inside. Let's substitute them inside. Press the calculator. So you will get this one as the positive 0.602. I direct press the calculator. So I will not going to show this anymore. Just direct press the calculator and it's positive. This will give you negative 0.634 and it's negative. Okay. So therefore, because of there is changes of sign between 1.2 and 1.3, so therefore the equations has a root between 1.2 and 1.3. Done. So this will be the answer for the question number 5C. And move on. We have a question number 6. Now we take a look at question number 6. We have C1, a curve C1 that has the equations of y equal to the x minus a x over the x minus 2a. We want to sketch the graph for C1. So the C1 will need to find the vertical asymptote, which is the x is equal to the 2a. Your horizontal asymptote is y equal to 1. And then when your x is a 0, when the x is a 0, you get the y is equals to the half. When the y is equal to 0, you get your x is equal to 8. So these are the informations that we have. Based on these informations, we can actually sketch the graph, and your graph will look like this. Okay, so this is a to A. This is your vertical asymptote, and this is a 1 horizontal asymptote. This is a half. So your graph will be like this and like this. Draw properly. Okay, so this will be the graph for the y equal to the x minus a over the x minus the 2a. That is the answer for 6a. Now we move on to the 6b. Part 1. So we're having a 2 curve over here. We have a C2 that look like this, and a C3 that look like this. And the C2, they want us to find the stationary point. So to find the stationary point, we need to do the differentiations, dy dx. So over here, we just apply the chain rule, dy dx is equal to 2 of this. And this one is keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. Simplify it, you get 2x minus a, and then negative a divided by the x minus 2a cubed. That is your dy dx. And to find stationary point, your dy dx is a 0, which means that the x, actually x is a, direct x is a. Okay, so you have only one stationary point here, and we're looking for points. So when the x is equal to a, we need to find the y. The y will be 0. So therefore, your stationary point is a 0. That is the answer for the number 6b, part 1. Now move on, we have a 6b, part 2. Now we want to find the intersections between the curve C2 and C3. So to find the intersections between C2 and C3, C2, your y is equals to the x minus a over the x minus 2a squared. That is equation 1. And then your C3 is y equal to the modulus. Okay. So to make it easier for us to solve the problem, we just let this call the u. So you will have 1 equal to 2. You will have a u square equals to the modulus u, which means that the u square is equal to the positive u and the u square is equal to the negative u. So over here, you can factorize it. Over here, you can factorize it. So your u will be equal to 0, u is equal to 1. Your u is equal to the 0, and u is a negative 1. So for u equal to 0, which means x minus a over the x minus 2a is equal to 0. Another one is x minus a over the x minus 2a is equal to 1. Okay. Then uh, this part is repeated. this is repeated. And then we do not need to repeat that, okay? Then we just write down the u is equals to the -1. Okay, so we have total 3 equations over here to be solved. So the first one, the answer is simple. The first one, the answer is A. This one is, we have x minus A equals to the x minus 2A. There will be no solutions. Over here, we will have x minus A equal to -x plus 2A. So we will be having x is equal to the 3 over 2A. Okay, so we have 2 answers here. And therefore, the intersection point so we have x equal to A. Just now, x equal to A, the y is equals to 0. And when x is a 3 over 2A, let's put it back into the equations. You can see that your y is equal to 1. Okay, so this is what we have. Okay, these are the intersection point that we have for the C2 and C3. So now, based on these 2 informations, for the B part 1 and the B part 2, we will proceed to the part C. We want to sketch these 2 graphs together, C2 and C3 together. So to sketch the C2, the graph, C3, the graph is easy. C3, the graph is based on the part A. You can see the C3 graph will be like this. Okay. Then the C2 graph is you square it. So when you square that, it will be look something like this. Because it's just now in B part 1, we show that we have a turning point, right? So you can see that you will have the graph something like this. This is the turning point. This is the stationary point. Right? So the stationary point is the same point as the intercept, x-intercept over here. Okay. So what you need to do is erase this. We want to put them together. So we try to draw the graph larger a little bit. Okay. So this is a, this is a 2A. This is a 0. This is a 1. This is a half. This is a vertical asymptote. That is a X. That is a Y. Okay. So your C3, we draw C3 first. C3, the graph look like this. That is a graph for C3. That is a half. Okay, that is a graph for C3. Then for the C2, the graph, it will be, because when your y is between 0 to 1, your y square is actually less than the y. Okay, so your graph will be lower. And then this one, you need to square it. 1 over 2, if you square it, you will get 1 over 4. So you're supposed to get something like that. Okay, you're supposed to get the graph lower. And you are having a minimum point. And after that, you go up. This part, it will be larger, greater. This is a turning point. And your graph will look like this. This is a 1 over 4. that is the intersection point. Just now we found that is a 3/2a. And this is the C2 over here. Okay, so you can see that this C2 will look like this. Then your C1, this is a C2, huh? That is your C1. Okay, so this is your C1, this is your C2. Okay, so this is the graph for the y square and the modulus y. Now we are looking for the set of solution. Okay, we are looking for the set of solutions that the y square less than or equal to the modulus of the y. So that means we are looking for the yellow color graph, which is below the below this graph, below the modulus graph. So over here we just need to let them equal, but just now we already let them equal. Okay, just now we already let them equal and we already solved them. We have the answer already. You can say that from the graph, okay, you can just say that from the graph, our answer, okay, wait for a while. Let me erase this. This one is, this is not needed. Okay, so you can see that if the answer, in order for the yellow graph lower than the modulus graph, so it will be here onward. Okay, so therefore from the graph, you can see that your x will be less than or equals to the 3/2a. Just like that, done. So this will be the answer for the question number 6. And move on. We have a question number 7. The 3 points over here, point A, B, C, each of them have a position vector as given here. And we want to find the equations of the plane ABC and leave the answer in the Cartesian form. So first of all, we write OA as a matrix form, -2 to -1, and OB will become -2, 1, 2, and OC will become 0, -2, 1. Then in order to find the plane equations of the ABC, I need to find the vector AB and the vector AC. So B minus A, you get a 0, -1, 3. C minus A, you get a 2, -4, 2. And we do the cross product. Okay, so this cross product will be 0, -1, 3, 2, -4, 2. And you will get 10i plus 6j plus 2k. And you can see that they all can multiple of 2. You can factorize the 2 out. You can get a 531. So my normal vector number 1, I will call it 531. Okay. Then after that, to find the equations of plane pi, equations of plane ABC. So you just need to have a 4 bracket like this. That is your x, y, z. That is your normal 531. Your normal also put it here. And this will be the position vector, either position vector A, position vector B, or position vector C. Over here, I put A. Then expand them, 5x plus 3y plus z is equal to the -10 plus 6 minus 1. It will be -11 plus 6. It will be a -5. Done. This will be the answer for 5A. Now move on, we have a 5B. Find the angle between the plane OBC. So to find the plane OBC, I need to have a normal vector for the OBC. So we take the OB cross with the OC, which is, need to refer back to the question. OB is a negative 2, 1, 2. OC is a 0, negative 2, 1. You do the cross product, and then you will get 5I plus 2J plus 4K. Okay, so to find the acute angle between the two planes, just do the dot product between them. So this is the normal number one. Normal number one just now from part A is a 531. And then this is the normal for number 2. For 531, it will be a 25 plus 9 plus 1. This one will be 25 plus 4 plus 16. In order to get acute angle, you put modulus. So your cos theta will be the modulus 25 plus 6 plus 4 divided by square root of 35 and square root of 45. So you press a calculator, then you can get the answer in, I will leave the answer in degree, 1 decimal place, 28.1 degree. That's all. So now we move on to the part B, part C. Okay, so part C is a point, there's a point D, given the position vector as di minus the j. So we just write the OD as a d minus 1, 0. Okay, so they mentioned that the shorter distance between AB and CD is a certain. Okay, so find the values of the CD. So I need to find the, we already have AB in the part A just now. AB is 0, negative 1, 3. And then we need to find CD, directional vector of CD. So CD is a D, 1, negative 1. Okay. Now I need to do the cross product between AB and CD. Cross product between AB and CD. So I have a 0, negative 1, 3. D1, negative 1. I have a negative 2I plus 3dj plus the dk. Okay, so this is what I'm having now. Then I need to have one more thing. I need to either I take the A connect with the C or the B connect with the C. Okay, so either I take AC or BC or AD or BD, but I will usually I just take AC. Okay, so we find AC. So it's OA minus OC. OA minus OC, you get 2, negative 4, 2. Okay, then given the shorter distance between AB and CD is a certain, so by using the formula, so the formula, we just memorize the formula. So the formula will be the AC dot with the cross product just now divided by the magnitude of the cross product. It will equal to the certain. Okay, so this is the formula. We just memorize it. Then if you expand them, you get the negative 4 minus the 12d plus 2d modulus is equals to the square root 10 multiplied by 4 plus 10d squared. Okay, then we square both sides. So if we square both sides, then you will get this one as the negative 4 minus a 10d square equals to the 10 multiplied 4 plus 10d squared. Okay, so you will get this as a 100d square minus plus with the 80d plus a 16 is equals to the 100d square plus the 40. Cancel the 100d square, so your d will be 24 divided by 80. 24 divided by 80 is 3/10. So done. We have found the value of D, and this will be the last part of the questions, last part of this paper. We'll stop the video here. I'll see you next time. Bye-bye.